Good morning or good afternoon, everyone. My name is Enrique Losoya, and I'm an interdisciplinary engineering PhD student at Texas A&M University. And I'll be presenting on behalf of my teammates this poster titled COVID-19 Vaccine Supply Chains, which focuses on its manufacturing processes in the United States. By the way, the information presented here is also available in a dynamic report online. So please feel free to use your camera app on your phone to scan this QR code so that it takes you to this report on your phone. As all of us are aware, the COVID-19 pandemic has severely disrupted supply chains around the world and in the United States. So to contribute towards helping on reducing these disruptions, our research group is working in collaboration with the CBTS Center of Excellence at Texas A&M University on two projects. One, which is called the R7 project, represented by the left-hand side of this figure, and it is tasked with developing a qualitative Bayesian network following a common risk framework that aims to capture the central cause and effect relationships, the dynamics and interactions of a system. And in this case, the system is the international and domestic supply chain. Now, the other project is called the R13 project. That one is focused on providing relevant information on the bilateral trade between the United States and Mexico by bringing together experts from academia, government, and industry officials through a task force. This to provide subject matter expertise on the evaluation and validation of potential impacts to supply chains. Now, R13 has a heavily focused technological integration component, which is the development and operation of a web-based dashboard and a data lake system. The data lake system facilitates students like myself and researchers to use, process, and store reliable and curated data behind the university firewalls on an on-premise cluster of the servers. Now, to couple these two projects together, we have selected 4 research problems to validate R7's risk-based model and to integrate data into the data lake system, as well as to generate that information on the dashboard. Now, moving on into the current initial ongoing results, we have the table shown here summarizes and compares relevant information between the emergency authorized COVID-19 vaccines. This is Pfizer, Moderna's, and Johnson & Johnson's, including some of the reported manufacturing bottlenecks. The pie chart on the left shows the total pre-order available supply for the United States compared to the share of distributed doses as of March 31st. And on the right-hand side, you could see the approximate wholesale prices per patient for the leading vaccines compared to the flu vaccine price for those that are uninsured in the United States. Now, moving on into the identification of several facilities involved in the manufacturing processes of these vaccines. This map shows all the facilities and for which one are involved in, for which process these facilities are involved in. And it comes as no surprise that most of the small to medium pharmaceutical companies, such as the German-based BioNTech and Moderna, usually patent and outsource some components of this process to several specialized service providers. However, with the exception of Pfizer's manufacturing process, where Pfizer is mostly vertically integrated from manufacturing all the way almost to distribution, as it is a leading and established global pharmaceutical company, has the capacity to do this. Now, on the right-hand side of this map, we show particular steps for each one of these 3 vaccine supply chains, from procurement, manufacturing capacity, and distribution efforts, and as well as some other information. A similar process and analysis was done for the Mexican pre-order vaccines and the distribution efforts happening down there. However, I won't go into the details over there. Now, in conclusions, I present some of the key takeaways for each one of these 3 manufacturing pharmaceuticals and vaccines. But yeah, the conclusions are: we have identified reliable sources of information, pre-order vaccine supply and its main manufacturing elements. We have identified those sources of information to target and ingest into the data lake system. The R7 risk model was successfully validated, at least qualitatively, for using this research problem. And we're also working on applying more quantitative analysis and methodologies focused on a specific bilateral supply chain to provide relevant information and forecasting in almost real time to decision makers. With this, I would like to acknowledge DHS Office of University Programs for giving us the opportunity to present our work in this venue, for funding our work through the CBTS Center of Excellence at Texas A&M. And I will also like to thank you for your time and your attention today. I really appreciate it. Thank you very much.